Good day, everyone. My name is Judith. I come from the Bauhaus-Universität in Weimar, and I'm going to present today my topic, GIS and BIM integration approaches for early railway planning phases. And I would like to dive into that topic by first pointing out the specifics of railway planning, because we have some differences to the, I would say, conventional planning due to the fact that railway planning has some specific characteristics. First of that, it is the spatial extent of projects. So especially when we're talking about really big projects, we have a huge planning space. We are crossing borders of at least municipalities, but also of countries regarding the project. Then we have, of course, have a big environmental impact on flora and fauna, and also on human settlements. Like, that is one aspect. Another aspect is, which is, I think, pretty different from other projects, is that we have a very challenging project management. For example, we have long project runtime from the moment where is the decision made, okay, we are going to build this project, over the planning phase and finally to the operation. Those can not only be years, but maybe decades. So also connected to that, we have a very high amount of contracted stakeholders, like due to fluctuation and over the time and so on. And we have a high political and public interest in those type of projects. The third aspect is that, of course, we have a high technical complexity and diversity. We have many involved disciplines that are working on these types of projects. We have therefore also very big heterogeneous data to be incorporated, and we have now coming to the early planning phases or even pre-planning phases, we have already a high requirement for information at an early stage. Important decisions regarding railway projects are often made at a very early stage, so before the project officially has even started. And the impact of those decisions are usually long-term and crucial also for the project. So why are we talking in this context about BIM and GIS? GIS for Geo-Information System. Therefore, we have to first take a look on what the differences are between BIM and GIS. BIM, as we all know, has the focus on the building. We are going down on a building component scale, and we usually at least neglect the surroundings. We are more interested in the building components themselves. Meanwhile, when we are taking a look on the GIS side, the focus is mostly the city, region, country, continent, whatever, but we are talking about a more global scale. And the buildings are usually only incorporated, showing the contours or the shells, so we are acting on two very different scales, and both approaches also contradict each other in that case. Why is that now a problem, let's say? What is the problem with that? As I said before, decision-making at an early stage is crucial for the later project course, but we also need to, at the same time, consider GIS data at this specifically early stage due to the scale of railway projects. And the collected data needs to be brought to the BIM-based planning process, because I'm already collecting data that I would like to use at a later stage in order to do a better planning for railway. So we can say we have a high need for BIM and GIS integration for railway. So the two questions I would like to focus on mainly, or we have been focusing on writing the paper, was which open data standards exist to make BIM and GIS integration for railway, especially for railway, happen, what is already there. And then in our case study, we wanted to find out if open formats and open geodata can be used for early context modeling in railway at this specifically early stage, where usually there is no surveyed data or very few survey data yet accessible, because the project has not started yet. To dive into that, I would like to start with the literature review. So first, what did we do? We first tried to get an overview over the literature and the standards that are there in a quantitative way, and there we could see, this is now an example from the data bank Scopus, but we, as you can see, there is a trend actually. We have looked into that from 2014 until 2021. 2022 is still an ongoing year, so we did not consider that yet in this graph. But there you can see when one looks for BIM, GIS integration, in those combination, the keywords, there is somehow a trend and a growing interest in that topic. And correlating with that also when it comes to the topic of railway in those, in this context. In the qualitative literature review, we were taking a deeper look into what data formats and what data models and standards are already there. I will not go too deep into that. This is maybe a bit overwhelming for that presentation, but I will point out quickly the findings that we were having there. So we found that many approaches are trying to bridge both worlds, also regarding railway infrastructures. There is a growing interest in unified approaches. I think some of the other presenters have already mentioned something like that. So about the idea of not maintaining separate data formats, but somehow bringing them together in unified approaches. And there are several approaches regarding conversion, like, for example, from Professor Tauscher, the graph geometry conversion, triple graph conversion, or other conversion algorithms that have been developed there. So what we were doing is to figure them out and see how they are related to each other. That is somehow the output of the qualitative literature review, focusing in this case on 3D data formats. We have identified then promising ones for railway, which is on one hand the infra GML, formerly known as the land infra data model, which is right now also an OGC standard, Open Geospatial Consortium standard, somehow the GIS pendant to the Building Smart and BIM. And the infra application domain extension for the city GML data model, which are promising approaches already also to convert the railway objects. Coming to our case study, I would like to present shortly the methodology. The goal of this case study, as I have said before, was to find out if we can, from open geodata and with the help of open formats, to form some kind of low threshold context model at this early stage, so to work with data which is already there and easily accessible. And in order to do that, first, of course, we were collecting this type of data. So interesting for railway planning at that stage is, for example, OpenStreetMap data that we can get from streets and railway alignments and so on. Cadastre, digital elevation models, so the topography, of course. LiDAR scans or other point clouds are also important, or satellite, whatever is there, we can take somehow. In the next step, there is usually some kind of pre-processing necessary, so coordinate transformation, cleaning, editing, even deleting, cutting, whatever, merging some of those pre-processing steps. And then that is an optional step. Of course, one can enrich the information that is there even more. So adding additional information, maybe from external sources or expert knowledge or whatever that additional information could mean. And then comes the creation of the context model or the consolidation. Finally, the conversion GIS to BIM can happen using open formats. And this end product, I would say, is then ready to be used in the consecutive planning process, because that I can take now as a basis for my further railway planning. Coming to the implementation, how did we do that? We considered several different data input. So, for example, georeferenced photos from surveying flights. We used point clouds from airborne laser scans. We had cadastre maps. We had also city GML data, so a digital city model in LOD2. This data, for example, is openly accessible via which is called Geoportal Thüringen. So the Free State of Thuringia provides some kind of open geodata that we could use for that. And the rest of that we got from OpenStreetMap and consolidating that more or less. The people that are familiar with the city of Weimar can maybe recognize that this is the area of the main station there. So we have consolidated that, and this is more or less the databases that we were having. As I said before, the pre-processing can be of various kinds, I would say. I would just want to give a brief explanation on how a pre-processing step could look like. So we had the point clouds, as I said before, from this air surveying flights. And first what we did with that was to create a mesh in order to have a 3D topography in the end that we can work with. We converted that to OBJ using the open tool Cloud Compare, and then took the 2D satellite pictures and mapped them onto the 3D topography. For that we used not an open program but another one, but it can also be done with open programs. Finally, we coordinated it with the digital city model, and that is somehow the outcome that we had. So from open geodata, we were able to have this low threshold context model in the end. I can also show you a comparison here. So that is more or less the data that we had at the beginning, and with relatively easy steps, we were able to have this context model. So you can even see there on the left or on the right that there is also the topography. So we have this 3D context somehow, which is really nice to make then early decisions at that early phases without already spending a lot of money on surveying, or without even being able to spend a lot of money on surveys and so on. So that was somehow the idea behind that. I come now to the conclusion and outlook. As said before, the GIS data has to be considered at the early stage, so pre-planning, I mean with that. The literature review has shown possible open data models and implementations for a BIM and GIS conversion of railway objects. And the case study has shown that relatively easy, and with the help of geodata, open geodata and open formats, we can create those types of models that have a benefit for later planning phases. Where would we like to go from there on? I think we would like to expand the case study for the identified formats. We only used parts of them that we have identified in the literature review, but of course we want to extend that a little bit. And also what is actually the interesting part is which analyses can be run based on those context models, like how can I quantify it, and how can I really quantify the improvement that I can figure out with that in the later planning process. That's the end of my presentation, and thank you, and I'm looking forward for question and feedback.